The flag register in 8085 contains 5 flags that reflects the outcome of ALU, which is stored inside the accumulator. And this flag is essential for conditional branching operations as well as decision-making operations. And we have these 5 flags, namely this carry flag, this parity flag, auxiliary carry 0, and we have sign flag. So let's see one by one these flags, what these flags are and what are their purposes. Okay. At the first we have this carry flag at the bit number 0. So what is this carry flag? And this carry flag will be set when there's a carry in addition, or there's a borrow in subtraction operation. Let's take an example. So for addition, let's take two numbers, A5 and 7A. Okay, let's add these two numbers. Let's first convert these hexadecimal numbers into their binary counterparts. It's 1 0 1 0 0 1 0 1 and 7-ish 0 1 1 1 and A-ish 1 0 1 0, and we have 1 1 1 1 1. This is 0, this is 0, and this is 0, and we have 1 as a carry. So the two numbers are of 8 bits and the result is of 9 bits. So this additional bit will go to the carry. Okay, and in this kind of situation, when there's a carry out from addition of two numbers, this will set the carry flag, and this is for addition. And for subtraction also, there's a possibility that this carry flag will be set when there's a borrow. Since there's no borrow flag, there's no dedicated borrow flag, this carry flag will be used to indicate borrow in subtraction operation. Let's take an example. For subtraction, let's take 3-1 hexadecimal, and we take 4-0 hexadecimal. Okay, let's convert these two numbers into binary. 0 0 1 1 0 0 0 1 0 1 0 0 0 0 0 0. If we subtract these two numbers, we get 1 0 0 0 1 1 1 1, and we have another 1 as a borrow. This is the answer, and we have a borrow. This borrow will be reflected in the carry flag. In this way, this carry out or this borrow generates this carry flag. And then we have this parity flag. At the bit number 2, we have parity flags. This parity flag will be set when there's even number of ones in the result. Let's take an example. Let's add two numbers. Okay, 3AH. If we convert it into binary, we have 0011, 1010, 54H. This is 0101, 0100. Okay, if we add these two numbers, what we get is 0111, 0001. And in this situation, the answer is of uh, 4 ones, right? So there are even number of ones, so parity flag will be set. Okay, once again, this parity flag will be set when uh, there is even number of ones, which is due to an arithmetic operation or a logical operation. Okay, and this parity flag will be useful when there is uh, data transfer in digital data transfer, and we have to check it. Okay, this once again, this parity is useful when we want to check whether the digital data we transmitted is correct or not. Okay, so this is all about this parity flag. And then we have this auxiliary carry. So this auxiliary carry flag will be set when there's a carry from lower nibble to upper nibble, or there's a carry from third bit to the fourth bit. Okay, let's take an example. Let's add two numbers. So let's say CA and 46. These are all in hexadecimal. If we convert these two numbers into equivalent binary, we have 1100, 1010, 0100, 0110. Okay, so this is 0, this is 0, this is 1101, this is 0, and there's a carry 1, so this is 0, and from this to this there's a carry, right? Or we can say from the lower nibble to upper nibble there's a carry. So in this kind of situation, this auxiliary carry flag is set. Or we can say if there is a carry from third bit to the fourth bit, this auxiliary carry flag is set. And this auxiliary carry flag is not accessible. It's not accessible most of the time to us, to the users, and it is used internally for BCD operations. Okay, this auxiliary carry flag is exclusively used for BCD operations. Okay, and then we have this zero flag. Okay, this zero flag will be set when the answers have all the bits at 0. anything else. At this situation, this zero flag will be set. Okay. Okay. At the last, we have this sign flag. Okay. When is the sign flag set? When our answer, when our result has 1 as the most significant bit. Say for example, let's add two numbers, 1 0 0 0 0 1 0 0 0 1 0 0 1 0 1 1. If we add these two numbers, this is 1 1 1 1 0 0 1 1. So the MSB, the most significant bit is 1. So this sign flag is set. Okay. What is the use of this sign flag? And what does this mean? Whether this number is negative or positive depends on the users. Okay. The number system we have done so far is of all unsigned number. Okay. Unsigned number in the sense that the number has no sign and all the numbers are assumed to be positive number. Okay. Okay. Taking the situation of this, let's look at what are signed numbers and unsigned numbers. Okay. And how can we do the operations in signed number? Let's have a look. Okay. Okay, for the unsigned number, I think we have all understood. And for the signed number, okay, what does signed number mean? Signed number. So in the signed number, the most significant bit represents the sign of the number. So for example, if we have a 4-digit number, 0 1 0 0, say 1 1 0 0. So in the sign number system, this most significant bit is 0. So this is a positive number. If the most significant bit is 1, this means that in the sign number, this means that this is a negative number. Okay. So how to represent negative number? Okay. Let's think of a number like let's say let's take positive 10. How to represent positive 10? So it must be 8 plus 2. So it should start with 0 to represent as positive number, and we have 1. This is 8 4 2 1. So this is positive 10. And then how to represent its negative counterparts means negative 10. So for that purpose, we have to first take the 2's complement. And to take the 2's complement, we have to first take 1's complement. Okay. If we have to take the 1's complement, it results in 1 0 1 0 1. This is 1's complement. This is 1's complement. 1's complement. And to take the 2's complement, we have to add 1 to the 1's complement. So this is 0, this is 1, this is 1 0 1. So this is 2's complement. Okay, this is 2's complement format, and this is sign number, and it represents minus 10. Whether this is sign number or unsigned number depends on the user, depends on the interpretation of the user. Okay, if you want to take a sign number, we have to take all the numbers as sign number. So for example, in sign number this represents -10. How? 1 0 1 1 0. As we have seen that this most significant bit represents the sign bit. Okay, so this is if we look at the weights, this is 1, this is 2, 4, this is 8, this is 16. So this 1 represents -16 plus this is 4, this is 2. So if we add this together, we get -10. So this is how we represent -10 in sign number. Okay. So for example, this 2's complement method can be used to subtract two numbers without subtracting in the sense that by adding two numbers, which is with one of the numbers, if one of the numbers is negative, so that addition becomes subtraction. So for example, if we want to subtract 4 from 10, so if we want to operate this operation 10 minus 4, what we can do is that we have to represent. So for this we have to take at least 5 bits, right? For 10 it is 1 0 1 0. So this is 10. And what about 4? 1 0 0 0 0. This is 4. And what we have to do is that we have to take the 2's complement, and by taking 2's complement we will convert this 4 into -4. Okay, so if we have to take 1's complement, this is 1 1 0 1 1, and then if we add 1, this is 1 1 0 1 1 0 1 1 1. Okay, and this number represents -4. How? This represents -16. This represents +8. This represents +4. If we add together, this is 12. -16 plus 12. This is -4. So this is how we can represent sign number. And I think we can wrap up here, explaining how this flag registers are, and the conditions when this flag registers and these flag bits are set or unset.